All right, in this example, we are asked to estimate the intervals where the graph is increasing and concave up, increasing and concave down, decreasing and concave up, decreasing and concave down. All right, so we just want to find the intervals where these things are true. So I think what I'm going to do at first, I'm just going to use my highlighter, and I'm going to find the portions of the graph that are concave up and concave down. So I think I'll use, let's use green for concave up, and I'll use pink for concave down. All right, so concave down or concave up looks like a U, right? So it kind of looks like from here to about there. It looks like it's concave up, right? And then we switch from that to concave down, right? So from there to, I don't know, about there. We're just going to estimate, right? And then it looks like we go to concave up again. So this portion of the graph looks like it's concave up. So I'm just marking the concavity. And then here it's concave down too. So this could have started here. All right. So pink is concave. I can make a little key even. Pink is concave down and green is concave up. All right. So this is concave down. Green means concave up. All right. So now we have the concavity marked. Now let's look at increasing and decreasing. Let's look at whether the functions are increasing and decreasing or decreasing. So it looks like the graph is changing direction about there. So not quite -2, right? Somewhere between -2 and -1. And it's changing direction here as well. I can kind of show it at 0. It's kind of hard to see because the axis is there. It's also changing direction up here, right? So let's just kind of, we'll say that's about 4. We'll just estimate that to be 4. That's easier. It might be 3.8, but I don't know. And then it's also changing direction here, right? So you can see at these maxima and minima points, all right, the places where it changes directions are also where we end up with a maximum or minimum in the function. So you don't have to worry about that yet. That's 109. You'll work on problems where you're trying to find the maximum or minimum of a function. All right, so we've marked this up, and we have some intervals that are increasing, some that are decreasing, some that are concave up, and some that are concave down. All right, so let's see if we can find first of all the intervals where it's increasing and concave up. All right, so it's increasing here, right, from -3 to whatever that is, -1.8 or something. And then it's decreasing here, decreasing there. And then it's increasing again, right? So it's increasing here. And it's increasing here as well. And it's decreasing here. And it's decreasing here. And then it's increasing again. All right, so let's look at those places where it's increasing. Well, here it's increasing and it's concave down, so we won't worry about that. Here it's decreasing, here it's increasing, and it's green, so we said it was concave up. So it looks like the interval from about, I'm just going to say 0 to about 2. This interval here between 0 and 2 is increasing and concave up. Here it's increasing, but it's concave down again. It's decreasing and concave down. Here it's decreasing, and here again it's increasing. It's increasing, and it's curved upward. So we have another interval from 7 to about 8 where it's increasing and concave up. All right, let's now look for the places where it's increasing and concave down. All right, so we were just looking at the pink portions of the curves because those are the places where it's concave down. And so we can see right away the interval from -3 to about wherever this line is. Let's just say a -1.8 roughly. It's increasing and it's concave down, right? It's curved downward. All right, let's look at another. We're looking at concave down is pink, and when we want increasing and concave down. So see, we're seeing another one here from about 2 to about 4, between 2 and 4. It looks like it's also increasing and concave down. All right, and then the only other piece that's concave down is here, but it's decreasing. All right, decreasing and concave up. All right, so concave up is green, and we want to find the intervals where it's decreasing. So decreasing and green. All right, so we can see the first one is from about, looks like about -1 to 0, right? Right in this, from -1 to 0, it's decreasing and concave up. And then it's increasing, and then we can see over here between about 6 and 7, right? So for x between 6 and 7, it's also decreasing and concave up. All right, so finally we're looking for the places where the function is decreasing and concave down. All right, so concave down is pink, and we want to find the portions of the pink highlighted areas that are also decreasing. All right, so it looks like the first one is from about, so we said it was -1.8. Right here between -1.8 and about 1, or sorry, -1. It's decreasing and concave. Oops, hang on. No, yeah. Decreasing and concave down. And then we have another interval. So we're looking at concave down and decreasing. So it looks like this interval here from 4 to about 6. So for 4 less than x less than 6. Looks like another part where it's decreasing and concave down. Okay, so if we should have all the intervals covered now, right? If we kind of started at -3, we have -3 to -1.8 right here, -1.8 to -1, -1 to 0, 0 to 2, 2 to 4, 4 to 6, and 7 to 8. So we have got 4 to 6, oh wait, and 6 to 7, and then 7 to 8. So we've got all the intervals covered now. And so that's it. That's example 3, and I'll see you in the next video for the last example.